myself Sukumar, and our Texas project is power generation from speed breakers. In today's world, most of the students are using piezoelectric material under speed breakers to generate power, but it is very inefficient as well as it costs very high. And another way, students are using solar techniques. Solar techniques is also very inefficient and it costs very high. So in viewing these two techniques, we have founded an alternate way. In this alternate way, we are using some mechanical model and some electrical system to generate power generation, right? So in our mechanical system, right now I am going to explain about mechanical system. In mechanical system, we are using hum. This is a model of speed breakers, right? We are using a spring system. There is a sprocket and there is a chain. We are using chain using these sprockets, and there is a rim as well as there is a dynamo. In this system, we are transforming the potential energy or jerk into a rotational kinetic energy. This rotational kinetic energy of a sprocket is transformed into another rotational kinetic energy into the rim, and the rim will transform this kinetic energy to high RPM to this dynamo. Whenever high RPM is produced by this ring, this will produce a very high RPM to the dynamo, and dynamo will produce 9 volts, and this 9 volt is used to charge this battery. And this battery we are applying to the electrical system. In electrical system, we are using two portions. In first portion, we are converting the 9 volt to the 6 volt, and this 6 volt is applied to the another circuit, and this another circuit is going to use for the street lights. It will control the street lights automatically. Whenever sunlight goes on and off, the street lights automatically goes on and off. Now we are going to show the working model of our mechanical system. Our friend will come and he will place this hum, and this hum will go down and it will produce an RPM that will transform a high RPM to this dynamo. Now press will come. It is going to press this hum. Now you can see this is rotating this rim, and rotating this rim is producing a high RPM. This is transferring the high RPM to this dynamo, and as you can see, this dynamo will produce 8 volt, around 9 volt from here. We can see. Now we can see that very high RPM is produced to this dynamo, and this dynamo is producing an output of around 8.8 volt, and it is used to charge this battery. Now we have rotated this dynamo for 15 minutes. That has charged 30% of the total value of the battery. Now we are going to explain electronic circuit, and this portion of the circuit is going to convert 9 volt to 6 volt. In this circuit, we are using PNP transistor. This is regulator, and this is NPN transistor. And input side we are using 0.1 microfarad of capacitor, and the output side we are using 1 microfarad of capacitors. And this circuit will also have some additional facility, like it will has overcurrent protections, overload protections, as well as short circuit protections. Now the output of the 6 volt battery is applied to the another circuit. This circuit is consisted of LDR and 2 transistors, and this circuit has facility that will control this street light automatically. Whenever the sunlight goes on and off, accordingly this street light will goes on and off, and this will save efficient power. Now we will create an actual scenario in which we are going to switch off the light. When light is switched off, the street light will glow. As you can see, when the light is switched off, the street light is glowing. Now when we switch on the light, the street light will automatically off. Now we can see when the light is switched on, the street light is off. So we are saving